centers, but it is not a chiral molecule because it has a plane asymmetry. And that has a special name. A compound that has chiral centers, but it's not a chiral molecule because it has a plane asymmetry, has a special name. Anybody remember the name? Sounds just like a delicious Japanese soup. How many Japanese soups do you guys know? Maybe dumb question. Miso compound. Yes. spelled unlike the soup. Okay. By the way, one further thing about this. When I first learned this, I thought, well, that's kind of weird because if this thing's spinning, then it's only got that plane asymmetry if it's locked into that rotamer, to that conformer, right? But I already learned that this thing's spinning around, so as soon as it spins, it doesn't have a plane asymmetry anymore. That bothered me when I learned this, okay? And here's my hand-waving explanation for that. It is spinning. It's spinning quite fast, okay? And if you look at an old-fashioned airplane, a propeller-type airplane, or a helicopter, helicopters are weird. Plane propeller, all right? As it starts to turn, okay, you can see the propeller turning around and around and around. But after a while, all you're going to see is a disc, right? It's just spinning so fast, okay? At room temperature, that's essentially what happens with this. That creates a disc, okay? This also creates a disc, okay? Because of that plane and because of their orientation at those chiral centers, they create the same disc. Does that make sense? I told you it's hand waving, but there you go. That's all I got for you. Okay. I think I'll just mention real quick. You would not have the same type of stereochemistry outcome if you did this with that alkene. Okay, that is not E-stilbene or trans-stilbene. Does anybody know what this, remember what we call it? Cis or Z? You guys are good.
We're smart cookies on.
I guess so. I guess, yeah, I'm getting that. All right, what you would get with that, dude? On your product after a halogenation addition reaction, they're always opposite. It's called anti-addition. They add from opposite sides of the alkene. Okay. All right, those are still chiral centers. There's no plane asymmetry. Okay, that is a chiral molecule. Okay, kind of cool. Another thing we're talking about, I won't even draw stuff up there, but you remember this initial part where the bromine came from this side of the room. Yeah. Well, the bromine just as well. It's got no preference for that side of the alkene. It could have gone out into the hallway and made this dash, 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 and dash, 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 dash. Okay? The bromine can also pick either carbon. Okay. Doesn't matter. Even if the bromonium, that's what this intermediate is called, it's called a bromonium. Even if the bromonium has these as dashes, okay? Doesn't matter where this which one of the carbons the bromide attacks. If you start with E-stilbene, you will get this meso compound. Make sense? Okay. All right. I just want to real quickly, the setup for the reaction. You've done all of it before, but I just want to remind you super quick. I think you've used the air condenser. Yes, you did.
Yeah, because I broke the early math class.
Did you use the air condenser?
Yeah, because I broke the early math class.
But that's not making any sense. You don't use You don't use an air condenser with an Erlenmeyer flask.
Oh, just kidding.
What's that? Unless you took the air condenser and you smashed it. No, then.
Oh, never mind.
Okay, then you could break a Erlenmeyer flask with an air condenser. But they are two unrelated activities usually. Okay. So this is an air condenser. This is the water jacket. You don't need to bother to use this if your solvents and your chemicals and stuff have pretty high boiling point. They ain't gonna come out this top step. They'll condense on this glasswork well enough. Especially with a reaction that's a little bit shorter like this one is. You're gonna use your 10 mil round bottom flask. Okay, that's the smaller of the round bottom flasks. You put the blue nut over it. You put the never forgotten O-ring over that. Now that can screw together. Now you can clamp the air condenser and suspend the reaction. Okay? Okay. There we go. Yeah.
Do you want us to use this stir plate or the peanut?
Your choice. Does not matter. Okay, and then aluminum block real quick. All right. And that's pretty much your setup. Yeah, make sure it's centered at your stir plate so that it stirs nicely. Okay. We then do need to isolate our product, and in order to isolate our product, we're going to do that vacuum deal again, where we use the Hirsch funnel. We put a piece of filter paper in there. Hold on just a second, I'll grab that. Okay guys, so you got, don't forget your little rubber rubber adapter, filter adapter. Hirsch funnel goes in there like that. That dude fits in there. Okay. But we never want to, I don't want to put one of those big red hoses on here and then put it right into the pump, because some of that acetic acid will go into that pump and wreck it. Okay, so what do? Trap. Yeah, exactly. That's what this guy's for. Yeah, now we use two hoses. One hose goes there, one hose goes to the pump. Remember, do not put any strength in this. That guy will snap and you'll stab yourself. Okay, I've seen that one a few times. This guy doesn't need to be clamped. I just lay him down like that. One hose goes to there, one hose goes there. So grab these glass things on the end. You can use a little bit of water or soap with water. Screw it on there. It doesn't need to be all the way down on there. All right. Okay. Don't forget to put paper in here. Okay, a little bit of paper. And that's about it. At the very end, we're going to put it in a watch glass.
I think the procedure still says we take a melting point today. That's a long time ago. We take a melting point of our final product, the product at step 2. There's actually no analysis today. Okay? So at the very end, guys, almost done here. You got your watch glass, okay? You've weighed the bottom one, all right? You put all your stuff onto the watch glass. Put the paper on there too. We'll deal with it next week when everything's nice and dry. You put another watch glass on top of it. This is like what we did with our aspen the very first time. You go with tape, write your name, put it in your drawer. Move on if you like.